What is this curtain above our heads that gives us light in the morning and starts to shimmer at night? This was probably the first mental exploration of what is beyond the earth we stand, which we originally call Earth, where imagination and curiosity were our first fuel to the exploration of space. Some notable people in history who observed space were Ptolemy? Ptolemy? Copernicus, Aristotle, Galileo, and our lovely friend, Newton, again. Men's understanding of space had greatly improved since then, but were still limited to mathematics and imagination until World War II, when the Germans invented V2, the first rocket to reach the boundaries of space. In 1961, the first man to ever escape the Earth's atmosphere and into space was Russian cosmonaut Yuri Gagarin. Even the first woman to space was Russian. Her name was Valentina Tereshkova, who flew 2 years after Yuri Gagarin. Fast forward to more modern satellites. In 1972 and 1973, NASA launched 2 space probes named Pioneer 10 and Pioneer 11, which were meant to explore Jupiter and Saturn. The Pioneer 10 was used to study the asteroid belt of Jupiter. It then continued to study solar wind and cosmic rays in outer space. Wait a minute, now what's this solar wind all about? It's literally wind made by the sun. You can call it cosmic wind, though it probably wouldn't feel as nice as wind blowing on your face. This is because solar wind consists of electrons, protons, and alpha particles that escape from the sun due to nuclear reactions. Getting an astronaut to Mars would expose him to 15 times the annual radiation limit for a nuclear power plant worker. That is 15 times the amount you are able, not to say you should, take in a year. And this is just in 180 days, that's half a year. Powerful radiation not only causes long-term cancer risks, vision impairment, but also immediate effects such as vomiting and fatigue. Engineers still don't have effective methods to shield astronauts from radiation. A thicker hull can block low-energy cosmic rays, but any high-powered rays will just pass through, and it only reduces the threat by about 10%. The best way right now is to get onto the planet as fast as possible, as the bulk of the planet and its atmosphere will provide significant protection. A few years later, NASA launched Voyager 1 and Voyager 2, which would follow in the footsteps of the pioneers to Jupiter and Saturn. The Voyager 2 has even flew by Uranus and Neptune. After finishing their mission, the Voyagers are currently learning about the heliosphere. The heliosphere is a bubble created when plasma from the sun stops when it hits interstellar medium, that is the hydrogen and helium gas that permeates the Milky Way. Both Pioneers and Voyagers have a golden record on them. It's a phonograph, if you remember from the old times. In case any extraterrestrial life finds them, you can say hi, please do not attack us. These space probes have been deployed almost 40 years ago. More recent missions include the Mars Curiosity rover, which is exploring Mars to see if it can be the next Martian, and also the International Space Station, which collects data of long-term effects of being in space on humans, and it also houses other numerous scientific experiments including biology and physics. Cool, so how do they send these hundreds of kilograms of weight up into space? The Mars Curiosity rover weighs almost a ton. Well, the good old-fashioned way, of course, rockets. Yay! Although efforts and breakthroughs have been made for better propulsion systems, we are still stuck with rockets. But scientists have been creative with their propulsion methods. Have you seen the movie Martian? Yep, they featured the gravity slingshot and it actually works in real life.
So this is our Earth, and this is our spacecraft. As the spacecraft approaches, it has a velocity of u1. As it makes its way past the spaceship, past Earth, it goes here. It has a velocity of u2. Now, relative to the spacecraft, this Earth is stationary. Hence, its inlet velocity u1 is equal to its exit velocity u2. So now, what if we have a sun here? So relative to the sun, the planet has a velocity v. So the incoming spacecraft has a velocity of u minus v. as the spacecraft tracks its way across the Earth, it has a velocity of u plus v. So basically that's how gravity slingshot works. The spacecraft accelerates past the celestial body, takes its energy, and flies far, far away. Wait a second, I know my physics. How can you create energy out of nowhere? That doesn't obey the laws of physics. Well, basically we do not defy the laws of physics over here. As the mass of the Earth is approximately 5.97 times 10 to the power of 24, while the mass of the spacecraft is merely 3,000 plus kilograms. Hence, the spacecraft takes up kinetic energy from the planet and forces it into a lower orbit. However, the difference in displacement is so minuscule to the size of 10 over hundreds of a width of a hair that is barely noticeable. Thus, in celestial terms, it is negligible. Oh, I get it. Okay.
Exploring space using spacecraft is troublesome business. What if we could just sit back on Earth and explore space using telescopes?
Well then, one question. Have you ever seen how the other galaxy in the space looks like? Are they colorful? Dark? Invisible? Let us have a look at these few pictures of galaxy far away from Earth, which is taken from our most powerful Hubble. Ta-da! Can you guess which picture represents our closest galaxy? Yep, it's the Canis Major Dwarf Galaxy. A little fun fact about this one is that the distance between this galaxy to our solar system is much closer than our solar system to the center of the gravity. And another fun fact about the Andromeda galaxy is that it is the closest spiral galaxy to the Milky Way, and the distance is about 2 million light years away. Our technology had allowed us to observe planets much further away compared to the telescope made by Galileo. I will now introduce a few famous telescopes on the Earth's surface as well as in the space. From the Earth's surface, we have Mauna Kea Observatory, which is located in Hawaii, United States. While in the space, we have the Hubble Space Telescope, which is a space telescope that was launched into low Earth orbit in 1990s and remains in operation, aided by multiple serving missions as recently as 2009. A little fun fact about Hubble Space Telescope is that at 20 years old, Hubble runs on some old school computing technology, including a relatively ancient Intel 486 processor. Enough for the telescope thingy. Let me ask you a quick question. Have you ever wondered how the other galaxy will look like with your own eyes? Truth is, you are unable to see some of the galaxy with human eye due to the difference in wavelength of electromagnetic wave. Light from astronomical objects comes in a wide range of colors, each corresponding to a particular kind of electromagnetic wave. Now I will explain how a telescope can capture the image of another galaxy. Let's take Hubble as an example. Hubble can detect all the visible wavelength of light, plus many more that are invisible to human eyes, such as ultraviolet and infrared light. Lowest wavelength should be given a blue hue, the middle wavelength a green hue, and the highest wavelength should be red. It will turn up something like this figure. The finished image at the right is actually a combination of all the filtered image. Well then, I know you guys will be wondering, is there any future plan or improvement to be made? For now, one of the plans is to launch James Webb Space Telescope at October 2018. James Webb Space Telescope is the successor instrument to the Hubble Space Telescope and the Spitzer Space Telescope. It has unprecedented resolution and sensitivity from long wavelength visible light through near-infrared to the mid-infrared. It also has a larger and segmented 6.5 meter diameter mirror, which helps in collecting larger images from the outer space. One of NASA's future plans is to send a team of astronauts to Mars, which will take time around 6 months to reach the destination. Astronauts will need to communicate quickly with other spacecraft and in emergency even hold video conference. For this, NASA is developing a new communication system to operate at higher radio frequency and optical frequency using laser communication system. New internet system is being developed that will give each planet its own domain name, for example, www.alphabase.mars. The new system will compensate for a great time delay in communicating between body and space, which is 29 minutes for one way when Mars is closest to the Earth.
For the next few minutes, let's talk about the future of manned flight and unmanned flight in discovering the space. Japanese Icarus, nanocell D spacecraft, and sun jammer. What are these? These are solar sail. A solar sail is a form of spacecraft propulsion using radiation pressure exerted by sunlight on a large mirror. How does it work? Light from the sun is made out of photons. Imagine photon as massless tennis ball. When a tennis ball hits the fence, it transfers the momentum to the fence, which pushes the fence in the direction the ball was moving. Even though they have no mass at rest, they have momentum where they are moving at light speed. When light reflects off a surface like a mirror or a shiny piece of metal, they impart some of the momentum to the surface. Light is constantly streaming from the sun and is totally free. Solar sails have already been launched and deployed in the space. The closer to the sun you are, the better they work. Solar sail is actually a better solution to send humans off to discover more of the outer space because this is completely free. Next, Orion. It is a new NASA spacecraft for astronauts. It is essential in NASA's journey to Mars. It will carry astronauts farther into the solar system than ever before. So far, no man has been to the space in Orion yet. The first mission is called Exploration Mission 1, and it will last for about 25 days. It will make a big orbit around the moon and go farther into space than any people have traveled before. After that, it will begin with Exploration Mission 2, but this time with a crew, traveling the same path as Exploration Mission 1. The goal of Orion for 2020 is to carry astronauts to an asteroid, and by 2030, NASA's goal is for Orion to carry human explorers to Mars.
Speaking of spacecraft and propulsion, last month, NASA published a new peer-reviewed paper of the EM drive, a propulsion method without propellant. So, what is the EM drive? We are here to find out.
So it's a very simple device in engineering and physics terms, in that you've just got, all they've got is a cavity, which in some ways is similar to the kind of cavity you have in a microwave oven. It's just basically microwaves bouncing backwards and forwards. The thing that's different and a little strange about this cavity and why it seems to have these properties, or at least why they claim it has these properties, is because it's not a square cavity, it's actually a kind of a cone shape, so it's narrower at one end than it is at the other. And so you have your microwaves bouncing backwards and forwards, trapped in this cavity, but as you squeeze them when you get to the narrow end, the wavelength of the microwaves gets shorter. And so the wavelength of the microwaves changes as they bounce backwards and forwards in the cavity. And the reason why that's important is because, as well as particles carrying momentum, light carries momentum as well, and microwaves are just a form of light. And so it's just a low frequency form of light. And the momentum that the light carries depends on its wavelength. And so by creating a cavity in this way, it means the light, when it's at one end of the cavity, has a different momentum than when it's at the other end of the cavity. And that imbalance in momentum is what then creates the drive that pushes the thing forward, is the theory. Yeah. Oh, these things will never be any good for getting you out off the Earth's surface. You need much more intense chemical rockets to do that. But once you're up there, and if you're heading off into interstellar space, when you're no longer trying to really escape from anything gravity, then yeah, then it will work. And the nice thing is that the forces can be quite small, because of course you just integrate the force over time, right? You just keep, it just keeps going and going and going. So even though it doesn't accelerate like a Formula 1 car, over time it will still accelerate up to very high speeds, at least in theory.
So it's like the Pioneer and the Voyager outside space, so we can use like something that produces a small acceleration for them to navigate through their waves.
Exactly, yeah, that you don't need big forces, but especially if you're trying to travel supposing you were trying to create an interstellar spacecraft, it doesn't matter if you only accelerate quite slowly, because you've got a long time to get up to full speed. And so it doesn't matter that it's not a kind of traditional rocket in that sense, and that's why solar sails are quite effective, in that although they don't produce big accelerations, you just keep accelerating. So they will, it will produce over time, will accelerate you up to a high speed. It just won't get you there very quickly.